Thank you for joining this lesson. We're going to continue with this paper. We have already discussed the section 1 of this paper in our platform, that is a Shifting Grades Online School. So if you've not gone through the section 1, kindly find time and keep in touch with Shifting Grades Online School. You're going to benefit a lot. Remember to subscribe to this platform. Remember also to share with friends so that they may also benefit. Anyone preparing for the national exams in Kenya, Shifting Grades is recommended to them. Shifting Grades is highly recommended. So I recommend this channel to any serious students. When you go to school for the borders, please remember to update your friends about Shifting Grades Online School so that when you come for August holiday, you people will be flowing in good numbers. To the day scholars, Shifting Grades will be here for you even during the term too. And I hope you people shall benefit. Looking at number 17 now, the table below shows income tax rates for the year 2023. So we have the taxable income in Kenya shillings per month. And we're also having the other column for tax rates per month in percentages. We are told that in November 2023, Silas earned a basic salary of 38,320 Kenya shillings. In addition, he was entitled to a house allowance 12,800 shillings per month and medical allowance of 6,850 Kenya shillings. He also has a non-taxable risk allowance of 5,000 Kenya shillings a month. He contributes to a provident fund of 3,500 Kenya shillings. He also has a tax relief of 1,480 shillings per month. Part A, calculate Silas' taxable income that month, the month of November. Therefore, this month, we will calculate the taxable income as basic salary plus allowances. So the basic salary is 38,320. We add the taxable allowances, which are a house allowance 12,800 plus a medical allowance of 6,850. Remember, even though he enjoys a risk allowance, that risk allowance is non-taxable. So it is not included in the tax. So that one will not be taxed. So it is not part of the taxable income. 38,320. We add 12,800. Then we add 6,850. This is giving us 59,970. 970 Kenya shillings. So that is the taxable income that Mr. Silas is having for the month of November. Now, in part B, we are taught to calculate Silas' pay as you earn. That is payee, which is also called the net tax for the month of November 2023. This is the amount that we are going to tax. So when you look at the amount being taxed, or the taxable income, and the table up there, you discover that we shall tax up to the last part. So we begin taxing in the first band, whereby it is 15,000. So 15,000, the tax rate is 0. So actually, if there were people earning 15 or below, they would not be taxed by this government at that particular time. Then the next is, now in the second band, we shall have 27,000 minus 15. 27,000 minus 15,000, that gives us 12,000. So you subtract the previous limit. This one is at the rate of 10%, and it will give us Kenya shillings. Then in the next band, we are taxing that 7,000, we subtract the previous limit. So that 7,000 minus 27,000, giving us 10,000. And that will go at the rate of 15. So 10,000 at the rate of 15%. This will be 15,000 Kenya shillings. Then in the next, it will be 45,000 minus 37,000. This gives us 8,000 at the rate of 20. So 8,000 at the rate of 20%. This shall be 16,000. That's way. Then in the next band, it shall be 50,000 minus 45,000, giving us 5,000 at the rate of 25. 5,000 at the rate of 25%. So 5,000 at the rate of 25%. This is 1250 Kenya shillings. That is the tax. Then in the last band, we have taxed up to 50,000, but now the total taxable income is 57,970. Therefore, what amount has not yet been taxed? The total taxable income, we take 57,970, and we subtract the previous limit, 50,000. So 79,70 is the amount which is yet to be taxed. 79,70. So we are yet to tax 79,70 at the rate of 30%. So 79,70 at the rate of 30%. This is giving us 2391. So with all this, we can get what we call the gross tax, the total tax payable by Silas. This will be 00 plus 1,200 plus 1,500 plus 1,600 plus 1,250 plus 2391. This gives us 6951. So the gross tax is 6941. That way, 6941. Now with gross tax, then we can compute the payee. You know, for us to get the payee now, we need to deduct what we call the tax relief. This guy is enjoying a tax relief of 1480. So for us to get payee, we need to talk about the gross tax minus the tax relief. Therefore, we will talk about 6941 minus a tax relief of 1480. So the net tax is equivalent to 5461 Kenya shillings. So that is the amount that Silas paid for this particular month. But look at the next question. In the month of December 2023, Silas' tax in the last band was 2556 Kenya shillings. Calculate his net salary in December. Net salary in December. Therefore, the tax in the last band is changing from 2391. You know, we are having in November we had 2391, but now we are told in December the tax became 2556, which means the salary had changed. That's why the last band we had a bigger salary than previous. Yeah, we had a bigger tax than previous. So we're supposed to talk about now the new taxable income, the new taxable income. So what is the new taxable income according to this gentleman? The new taxable income will be, in the last band, there is a certain unknown amount which is being taxed at the rate of 30% to give us 25.56. So X shall be, we take 25.56 and we multiply by 100 over 30. This is giving us 85.20. 85.20. 85.20. So in the last band, we had 85.20, meaning that the taxable income in December was, when we take the upper limit of 50,000 and we add in the last band 85.20. So this was 58.520. This is the new taxable income. But now, for us to get what we are calling, net salary, we need to talk about, first of all, gross income. Gross income is all the amount that comes to the pocket of this individual, whether taxed or not. So there is the taxable income. Then we are having some hardship allowance here, which is not taxed. So it's part of the income, 5K. So we add 5,000 now. So gross income, all the income. This is going to be 63,520. 63,520. So this is the amount which we are calling the gross income. And it's good for you to know that now, that a net salary is given by gross income minus all deductions. All deductions. Therefore, we shall talk about, let me talk about all deductions first. All deductions. Now, for the month of December, we should talk about a new payee. The payee is not like this one. We had a new payee, and we just have to add, the tax was bigger, so we just add what is in the difference. So in the last band, he is now paying 25.56 instead of 23.91. So the difference of 165 is what has increased. So we should know that the new payee, this is for the deck, should be 54.61 plus 165. Yeah. So 56.26. So this is the new payee, because there is 165 extra. 165 extra. So the new payee now is 56.26. So when we take all the deductions now, the first deduction is payee. Then anything else that is paid by Silas, according to the communication here, is he contributes to a provident fund of 3500. So that is a deduction from his pay. So all deductions now, all deductions shall be 56.26 plus 3500, giving us 91.26. Therefore, the net salary shall be, when we take the gross income of 63,520 and we subtract 91.26. So 63,520 minus 91.26 gives us 54,394. Yeah, 54,394 Kenya shillings. So this is the net salary. In this question, there is something which is hidden, and we're supposed to know that the hidden thing here is deductions together with gross income. The gross income for Silas has also been hidden. If you're not careful, people will forget to add the non-taxable allowance, and they will start thinking that the taxable income is the one to treat as gross income. So gross income is a compilation of everything that Silas earns, and that is how we go about that question. Let's go to number 18. Is on angle properties of circles together with chords and tangents. Form 3 work and Form 2 work combined. In the figure below, PQR is a tangent to the circle at point Q. Then angle SQR is 54, as you can see, and VTQ is 41. As you can see at this point, 54 is here. Then we're also saying that UST 22. So as you can see, 22 is at this point. We also told that SUT is 40. SUT is 40 that way. So we have all the angles now indicated. All the angles have been indicated. Giving reasons, find the value of PQV. PQV, the angle at this point. PQV. So that angle is going to be 41. So this angle is the same as VTQ. Then this is equal to 41. Reason being, angle made by a chord and a tangent is equal to angle made by chord in the alternate segment. Angle made by the same chord in the alternate segment. I hope you guys are following, and I would encourage you in this topic, just have the properties in your fingertips. When you have the properties in your fingertips, it becomes so easy to deliver them when given a question. Like after seeing the angle of 41 at T, yours is to ask yourself, what chord has produced this angle? It is chord VQ. Is chord VQ making an angle with a tangent? Yes. Then that angle is equal to the angle of 41. So you can apply the same principle to conclude that the angle on the other side of T is also 54. 54 because it has been produced by SQ as a chord, and the chord SQ is making an angle with the tangent. So it's also 54. So if it's making 54 here, then it should subtend 54 in the alternate segment. That way, we can check some more other angles. UBT. UBT. The angle at this point will be equal to 22, according to me, because there's another 22 here. Remember, the angle at V has been produced by UT. UT produces the angle at V, and UT has also produced an angle at S equal to 22. Therefore, the angle should be equal to UTS. The angle should be equal to UST. Sorry, or yeah, UST should be equal to UST equal to 22. Angles subtended by the same chord are equal. This one should be understood from Form 2 work without struggling. That angles subtended by the same chord are usually equal that way. So we have the angle being equal to 22 degrees. Okay, the part 3 of this, we are told that PQT, we find PQT. PQT. All right, so that is the whole of this angle. PQT, the whole of this angle. The whole of this PQT. So we can work out a few angles now. We need now to work out a few angles. Then we come up with some conclusion. Okay. You can see there is an angle equal to 40. The angle at U equal to 40. That angle has been produced by TS. So TS is also producing an angle here equal to 40. And now we can use angles on a straight line for us to get the remaining angle on the other side of Q, whereby we take 180, then we subtract all these angles, 41, 40, and 54. 41, 40, and 54 along the tangent PQR, so that we get the remaining angle. That becomes exactly 45. That's 45. So if that is 45, then the angle PQT equals to 41 plus 45. This is it 86? Yeah. 86 degrees. The property that we have applied is that angles on a straight line add up to 180. Yeah, that's one of the properties we have applied. SUV. The angle SUV. Let's look at that. SUV. You know, SUV means this angle. SUV means the angle at this point. The angle at that point. So we are supposed to know that SUVQ is what we call a cyclic contralateral. That vertex, this one, and this one, they are touching the circumference of the circle. Therefore, SUVQ is a cyclic contralateral whereby all the vertices are touching the circumference of the circle. And what to say in a cyclic contralateral is that opposite angles are supplementary. They add up to 180. So if that is so, then it means the whole angle at Q is opposite to the angle at U. Therefore, they should add up to 180. Therefore, for us to get SUV, we must get the whole of this angle at Q, which is 85, 45, and 40. Then we subtract it from 180. So this should be 180 minus 85, giving us 95, I think. Yeah, 95 degrees. Opposite angles. In a cyclic contralateral, add up to 180 degrees. That way, that is the property that we have applied. Then we have a QXS. 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 That is the angle at this point. Remember, we have gotten 95 here. So we are talking about this angle now, the angle at that point. This one is going to be simple. Qxs, you know, with 54 and 22, we can get the angle at this point. We take 180. I'm using angles in a triangle. And I subtract 54 and 22. This gives me 104. If that is 104, then along the straight line, I should be able to take 180 and I subtract 104. This is 76. So it's going to be 76 degrees. This is angles on a straight line. They add up to 180 degrees. That's why we took 180 minus 104 to get 76. So those are the angles. Without straining, without a single strain, you just come up with these values. So you can get any angle as long as you know the properties that govern angles in a circle together with tangents and chords. That's simple. So now we proceed to number 19. It's my hope that you guys are still subscribing, following up with our platform, and sharing with friends. Remember, you can support our program by simply sending your support to the till number 497772. Any amount will go a long way. So we invite any supporters to our programs to use the till number attached so that we may keep growing together. Let's get to number 19. The first term of an arithmetic progression AP is 3. The sum of the first 6 terms of the AP is 78. Part 1, find the common difference of the AP. So in arithmetic progression, we should know how the sum of a given number of terms is calculated. So sum of a given number of terms is given by n over 2 into 2a plus n minus 1 multiplied by d. That's the general formula to get the sum of a given number of terms. So the sum is 78. This is the sum of the first 6 terms. So n is 6 over 2. 2 multiplied by the first term is 3 in the arithmetic progression, plus n, which is 6 minus 1. This should multiply by the unknown common difference that way. So that is the basic substitution of the formula as it is. Remember, simplification will give us 3. Yeah, so 78 equals to 3 into 6 plus 5 multiplied by d. 5 multiplied by d, yeah. So when you divide it through by the 3 here, we are getting 26 equals to 6 plus 5d. And at this point now, and group terms and now 20 being equal to 5d, so that the value of d becomes 4. So the common difference is 4. The first term is 3. That one we know. Then given that the sum of the first n terms of the AP is 406, find n. So we want to find the number of terms which give a sum of 406. Remember, the formula is already up there. So the sum is already known. 406 equals to n unknown over 2 into 2 multiplied by a, which is known, plus n minus 1 multiplied by the common difference, which we have just calculated, common difference of 4. that way. So we just substitute into the formula again. Remember, this question is just like the one above there, only that now we are just varying the unknown. Unknown is changing from, in the first question, it is D, which was unknown. Now, in the second question, it is N, which is not known. So now we work with 406 equals to N over 2 into 6 plus, this is 4N minus 4. That way. We can group terms and have 406 equals to N over 2 into 6 minus 4, that is 2, plus 4N. At such a point now, yeah, we can open brackets and have 406 being equal to, this is going to be N over 2 times 2, we get N, then N over 2 by 4N. 2 will cancel, by 2, 1, then 4 cancels, we get 2, N becomes squared. You see now? So we are having a quadratic equation here, which is supposed to be solved. So we can talk about 2N squared plus N. 2N squared plus N equals to 406. Because I want to solve it using the completing square method. So for me to use the completing square method, I'm supposed to make the left-hand side a perfect square. To make it a perfect square, I should add a constant C. And this constant C is given by the value of B over 2, then squared. Therefore, for me to apply this constant, I must ensure again that the value of A equals 1. Yeah, the value of A should equal 1. And for the value of A to equal 1, I'm supposed to divide the whole equation by 2 for me to have the value of A being equal to 1. So actually, I will not apply the completing square at that point. So I must first of all divide everything by 2 so that I have N squared plus half N. This is where I'll be adding a constant now, equals to 406. When I divide it by 2, I'm getting 203. 203. I also add a constant. So the constant C now can be obtained for me to make a perfect square on the left-hand side, such that I take half and I divide it by 2, then I square. This will be a quarter squared, and I'll get 1 over 16. So I'm getting 1 over 16. And also 1 over 16 on the right. All right? Yeah, that way. 1 over 16, that way. Therefore, I can do what we call factorization of the perfect square. So we are having a perfect square on the left. So we factorize the perfect square. To factorize a perfect square, you just take the square root of the first term, which is n, the sign that follows, which is a plus, the square root of the constant, which is a quarter, squared. This one is fully factorized. Equal to 2, 0, 3, and a 6. Now, the next thing that we shall do here is to find square root for both sides. Finding square root for both sides will give us n plus a quarter equals to square root on the right-hand side, which gives us 14 and a quarter. And you know square root will be plus or minus 14 and a quarter. Therefore, for me to remain with n, I have to use the first option on the square root, which is 14 and a quarter minus a quarter. and I get exactly 14, or n equals to negative 14 and a quarter, and I subtract a quarter, I'll get negative 14 and a half. Negative 14 and a half. And remember, we are working with n as a number of terms. So a given number of terms cannot be negative. Therefore, the value of n now, we set at positive 14, and we ignore the negative value of n. We ignore it because a certain number of terms cannot be negative. We can also see it is not an integer, it's a fraction. So it should be a specific number of terms, that is 14. So we settle with 14 terms. So the number of terms whose sum is 406. It's exactly 14. Yeah, exactly 14. Actually, a student may do this instead of working with that formula. A student may check the first term, which is the first term is 3, plus we are having a difference of 4. So you continue adding until you see what term will give us 406. So you start with 3, then you add this second term, then you add the third term, then the fourth term. So you add all of them until you see the number of terms which will give you 406, and you will still establish the number to be 14. Let's check the part B of this. A very interesting question which says that the second term, the fourth term, and the seventh terms of another AP, not the AP in part A now, form the first 3 terms of a geometric progression, that's a GP. If the common difference of the AP is 2, find part 1, the first term of the GP, and part 2, the sum of the first 7 terms of the GP to 4 significant figures. So let's work with interpreting first. How do we get nth term in an AP? How do we get nth term in an AP? So in a given AP, nth term, the nth term is given by A plus n minus 1, and this should be multiplied by D. So the second term that we are talking about should be A plus n minus 1, which means 2 minus 1, then multiplied by D. So that is the second term. Then the fourth term will be A plus n minus 1. So 4 minus 1, which is 3, multiplied by D that way. And finally, the seventh term. The seventh term is given by A plus 7 minus 1, 6, multiplied by D. But remember that the D is known to be 2. The common difference is 2. So if the common difference is 2, then it means this second term can still be established. So the terms are following one another as A plus D is 2. Then the fourth one, A plus 3 multiplied by D, which is 2, we get a 6. And finally, the third term, which is the seventh for the AP, is A plus 12. 6 times 2. So these terms, which are second, fourth, and seventh in an AP, are now consecutive in a GP. When we say that they are consecutive in a GP, and they are actually the first 3, then it means that we can talk about the common ratio for this particular GP, because in a GP, the terms are related using a common ratio, such that if we take the second term here, A plus 6, and we divide by the first one, there is a ratio that we get. And this ratio is also the same as when we take the third and we divide by the second. So that's what you're supposed to know. In a GP, there is a common ratio. So with this, we can do what you call a cross multiplication, such that A plus 6 multiplied by A plus 6, which is A plus 6 squared. Then this is equal to A plus 2 into A plus 12. Then now we can expand. A squared plus 12A plus 36. This is equal to, on the other side now, A times A, that's A squared, plus A times 12, 12A, then 2 times A, that's a 2A. So 12 and 2 becomes 14A, then plus 24, that is 2 times 12. So I have expanded that. So the next thing will be the grouping of terms together. A squared and A squared, they cancel one another because when you take one to the other side, they will just neutralize one another. Then this is 2A because of 14 minus 12. And when we take 36 minus 24, we get 12. So that the value of A can simplify to 6. The value of A is 6. Now, it's very good for you to know that this value of A is the first term in the AP. First term in the AP. That means now, the second term in this AP is here. The terms are here now. These are the terms in the GP now. So in the GP, we have A of 6 plus 2, giving us 8. Then 6 plus 6, giving us 12. And 6 plus 12, giving us 18. So that's how the terms are following one another. So we can conclude that for the GP, first term equals to 8. This is A, but we are in the process of working out first term in the GP. So that is not the first term that we add to set of 4. We are supposed to come up to 8. So because what is second in the AP becomes first in the GP. Second term in the AP becomes the first in the GP. That way. So this is first term for the AP. But now for the GP, first term is 8. With the terms listed that way, we can establish the common ratio. When we take 12 over 8, or we take 18 over 12, are we getting the same? Yes, 1.5. So there is a common ratio of 1.5 in this particular GP. So the GP is having a first term of 8 and a common ratio of 1.5. But now we are trying to find the sum of the first 7 terms of the GP. Sum of a given number of terms in a GP is usually given by A, the first term, into R power n minus 1 divided by R minus 1. Or the sum of a given number of terms in a GP can be given by A into 1 minus R power n divided by 1 minus R. That's it. So any of these two formulae can be used to calculate the sum of a given number of terms in a GP. So to substitute, you need to come up with first term 8, R 1.5 raised to 7 minus 1 divided by 1.5 minus 1. That way. Or using the second formula, 8 into 1 minus 1.5 raised to 7 out of 1 minus 1.5. Then now you use your calculator wisely now to do some substitution. You do some substitution very carefully. You start by 1.5 raised to 7. Then you subtract 1. After subtracting 1, you multiply by 8. Then after this, you divide by 0.5. I'm dividing by 0.5 because 1.5 minus 1 becomes 0.5. This is giving us 257 point 257 point 375, but we've been taught to 4 significant figures. So 375, we make this one a 4. So that we have now 4 significant figures. So we have it in 4 significant figures that way. Yeah, 4 significant figures. And it will be the same answer even when you substitute this one in your calculator. You replace that one in your calculator and you get the same answer. Very simple. So that's how we work the series and sequences question. Very simple. Students are just supposed to know the formula to be used in every case. And once you've known the formula, now what remains is to substitute in the formula. Remember, in this formula, we can have any variable becoming the question. The way we started in the AP, arithmetic progressions, arithmetic series, we start with the concept of getting nth term, you have to know it, and the concept of getting sum of a given number of terms. Then you should have known that, interestingly, we started with the unknown being the value of D, but later we had to work with the same formula, but the unknown being the value of N. So we can make any change and any amendment in the formula. Just make sure that you can apply it mathematically and conveniently. Thank you. Thank you for following. At number 20 now, a question on vectors. This is vector 2 actually. Yeah, this is vector 2. So let's work out a few questions here on vector. Remember to subscribe. Guys, remember to invite your friends. Remember to comment. Remember to react to our classes. Let's know how the going is. Let's know whether you are getting something. Let's know whether you are benefiting from this platform. Now we interpret the question here in number 20. A very interesting question. In the figure below, C is a point on AB. C is a point on AB, as you can see. Such that BA equals to 3BC. We also told that point D is the mid of the vector OA. So D is the mid. Then OC and BD intersect at point X, as you can see on the diagram. Given that the vector OA equals to A and vector OB equals to B, so this is vector A, this is vector B in the respective directions. Write down in terms of A and B, the vectors AB. So vector AB, we can move from A to O, then O to B. A to O, then O to B. So A to O means the reverse of OA. So negative A, then plus vector B. This can simplify to B, then the negative that way. Those are vectors. You indicate the vector notation that way. Then vector OC. Vector OC. For us to get to vector OC, let me do a few expressions here. We can do a few interpretations here. We are told that BA equals to 3 vector BC. That means we can get vector BC being equal to a third of vector BA. Yeah, vector BA. You see that? So this is a very serious interpretation that you're supposed to come up with. Again, you're supposed to relate vector BA now. So BA means from B to O, that is the reverse of B, then O to A. So B A equals to B to O, then O to A, that way. So the other one becomes vector A. That is the value of BC now. So this becomes negative a third B plus a third A. Or simply we start with the third A, then the negative a third of B to give us vector BC. Now with vector BC expressed, let's get to OC. OC will be given by O to B, then B to C. O to B is vector B. Then B to C equals to a third vector A minus a third vector B. Grouping terms will give us a third A. Then B minus a third becomes 2/3 vector. That's 2/3 vector B. There is another vector here, which is a vector BD. Vector BD, for us to get vector BD, we need to talk about BA, then BA, then A to D. Yeah, BA, then A to D. B to A, vector B to A. Remember, B to A is known. B to A is in the brackets here. B to A is there. Negative B plus A. Then plus AD. Vector AD is going to be half of AO. Half of AO. Because D is the mid. D is the mid. Therefore, AD becomes half of the full factor. Half of AO. Which means negative B plus A. Then AO is the reverse of vector A. That means vector A minus half becomes half vector A. Then there is minus B at one point. A minus half A. Then we have negative B. So the vectors have been expressed at that point. The vectors have been expressed. So with the vectors expressed that way, we can proceed now to work out part B, which is telling us that vector BX equals to H, the value of BD. Express OX in terms of AB and H. So because BX has been given, we need to work out OX, but we pass through OX. We express OX from O to X by passing through BX. So we need OA plus BX. OA plus BX. So OA is vector A plus BX, which is H, the value of BD, and it's up there. So with this now, we can open some brackets there to come up with the A vector plus half H vector A minus H vector B. That way. So with this, we should be in a position to understand that the terms with vector A, which are already together, we can factor the vector out such that we have 1 plus half H vector A, then minus h, the vector b. That is one expression for vector OX. We can also express vector OX using K, the value of OC. And you know OC has already been done. That is a third A plus 2/3 B. So that's vector B that way. So now we can talk about this expression being a third K, vector A plus 2/3 K, vector B. Second expression of OX. Now, with two expressions of the same vector, we can find H and K because we're taught to find H and K. So we can do it very conveniently now by equating the coefficients of each vector from the two different expressions. In this manner, if the coefficients of vector A are 1 plus half H in expression 1, we take 1 plus half H. This one should be equated to the coefficients of vector A in the second expression. And in the second expression, the coefficients of A are a third K. A third K, that way. This is one equation. Remember, this equation can be simplified so that we have one unknown expressed like K. So for us to express K, we need to multiply by 3 all through. So this becomes 3 plus 3 out of 2 H, Roman 1. That way. So that's one expression. Then we talk about the coefficients of vector B. We also equate them. So to equate the coefficients of vector B, then we will be having negative H from equation 1 being equal to, in the second equation, the coefficient of vector B is 2/3 the value of K. That way, 2/3 the value of K. So now we are having equation Roman 2. So the two equations now can be solved simultaneously for us to get the value of K and H. So because K has been expressed in equation 1, we can substitute it in equation 2. Negative H equals to 2/3. And instead of K, we have 3 plus 3/2, the value of H. So negative H equals to 2/3 by 3. We get 2. Then 2/3, 2/3 multiplied by 3/2. That gives us 1. So which is H that way. So we can now have, this one being solved as a 2H, 2H becoming 2. 2H equals to 2. So we have again to be very careful at that step. Very careful. Let me just check a few accuracies there, because we are supposed to be very keen in that solution. We must be very keen. From the first expression, of this one at this point, vector A, we were coming up with the vector OX by passing through BX. So we said the value of BX is supposed to be the value of X, OX, vector OX according to the diagram, OX according to the diagram is supposed to be given by O through B, that is OB, then B to X, OB plus BX. So this is supposed to be OB plus BX, OB plus BX. The vector OB as a value of B. Sorry for that, a value of B. So we should be having B at this point, B at that point, so that what is being grouped together here now is the vectors with B. The vectors with B is what we are grouping together, such that we have a B minus HB, then plus half HA. Now at this point now, vector B can be factored out to have 1 minus H, vector B, then plus half H, vector A, that way. So with that now, we say this is the first expression of OX, and the second expression of OX is here, the second expression. So when we work with equating coefficients, now, at this point, we're supposed to be now very careful. Let's look at it this way. We need to take the coefficient of vector A. In the second equation, we can see it is a third K. That is the coefficient of vector A. This one we equate with the coefficient of vector A in equation 1. So in equation 1, the coefficient of vector A is half H. That way. So with this, you see H can be expressed by multiplying by 2 through 2 over 3 K. So you multiply by 2 and by 2 to remain with H. Now this becomes our equation Roman 1. So that equation Roman 2 will come from equating the coefficients of vector B. Vector B, we have 2 over 3 K equals to, that is from equation 2. We have 2/3 K. It should be the same as 1 minus H, the coefficient in equation 1. 1 minus H, that way. So with this now, you can see this is the equation Roman 2. Then with that now, we can solve Roman 1 and Roman 2 simultaneously, such that because H has been expressed in equation 1, then we will say equation 2 becomes 2 over 3K equals to 1 minus, instead of H, 2 over 3K. So taken to the other side, 2 over 3 plus 2 over 3. You see that? 2 over 3 plus 2 over 3. That becomes 1 1/3, or simply 4 over 3. K, 4 over 3K equals to 1. So that, to get K itself, now we multiply by 3 over 4 both sides. So the value of K becomes 3 over 4. With the value of K as 3/4, we can also write the value of H. The value of H from this equation can be given by 2/3 the value of K. This is equal to 2 over 4, which is half. So H is half and K is 3/4. So that is those are the values of the constants H and K. Sorry for the inconvenience which is about to happen, but we identified it in the expression of OX in the second expression that way. So that's how we get the two constants. Whenever you're solving these questions, it's very easy for you to identify when you've done a mistake. You see, when we were almost finishing, I discovered that we are coming to get a certain constant, yet we know that these constants are fractions of the given vectors. So you just be extra attentive. Look at part D now. Show that B, X, and D are collinear. These are points which we're supposed to prove that they are collinear. Looking at the diagram, they are already lying on a straight line. So ours is to prove mathematically. B, X, and D, we prove that they are collinear. So we identify one of the vectors or two vectors which can be related amongst the 3 points. For example, we have just discovered a few constants here, and they are relating the vectors in this way, such that vector dx equals to hbd. bx equals to h. H is a bd. hbd. hbd. Now, you see, bx and bd are vectors derived from the provided points here. And if one equals to half the other one, it means one vector here is a scalar multiple of the other. And that one is an evidence that they are parallel vectors. Therefore, because one vector can be expressed in terms of the other, it means they are scalar multiples of one another. And we can conclude that bx is parallel to bd. And with that proven, we can also see that there is a point amongst the two vectors. There is a point which is appearing twice. That is point B. B is a common point. B is a common point. Hence, B, X, and D are collinear. Those are collinear points. For you to show collinearity, you show that two vectors derived from the provided coordinates are a multiple of one another, and that can be written directly that way. Then after that, you also show that amongst the vectors that you've expressed, there is a common point. That is point B, because in Bx, there is point B. In Bd, there is also point B. Then collinearity has been proven that way. Very simple. Very simple. Now let's get to number 21, which is a very good question here. Now in number 21, we are told that a triangle A prime, B prime, C prime is the image of triangle ABC with vertices A, 3, -1, and B, 1, 3. Then C, 4, 2. And a transformation represented by matrix M, which is a -1, -0.6, -0.8, -0.8, 0.6. The first thing we are taught to find is the coordinates of triangle. The coordinates of triangle A prime, B prime, C prime. We know that a matrix multiplied by object should give us image. Therefore, the matrix is -0.6. Remember, the matrix should pre-multiply. It should come first. That way, multiplied by, now we convert the coordinates of A, B, and C to be column vectors. 3, -1, that is for A. Then 1, 3, that's for B. And 4, 2, that's for C, equals 2. Now you start multiplying matrix. This row multiplied by the first column will give us the first coordinate. So we talk of -0.6. You open brackets for 3, then -0.8, open brackets for a -1. That gives us -1. Then the next should be the same row by the next column, such that -0.6, you open brackets for 1, you close brackets, minus 0.8, you open brackets for +3. That gives us a -3. Then you also talk about the same row and the last column here. So -0.6, you open brackets for 4. Then minus 0.8, you open brackets for 2. That gives us -4. That way. Then after this, now we go to the next row and the same columns. So -0.8 and 3, then +0.6 and -1. This gives us -3. Then in the next, it should be -0.8, you open brackets for 1, plus 0.6, you open brackets for 3. This gives us 1. In the next, we will have -0.8, you open brackets for 4, then plus 0.6, you open brackets for 2. This is giving us -2. That way. So now, with this, we can state the coordinates of A prime as -1, -3. Then B prime, we open brackets for -3, 1. Then C prime, we open brackets for -4, -2. -4, -2. Yeah, that way. -4, -2. And I hope for B, I've written it well. Yeah, I hope that one is well captured. Now, in part B, Roman 1, we are told on the grid below, draw the 2 triangles, ABC and also A prime, B prime, C prime. So let's come up with these 2 triangles. Allow me use the grid now on this page, because this one is a bit perfect. This one is a better grid compared to the previous one. I'll show you why. The reason why I've used a different grid. It's good for you to remember that transformations and matrices are always in the Kcse. Every year, actually, they come throughout. So you're supposed to be very conversant with them. You should be very conversant with those. Let me change the position of the y-axis, because I need the bigger values of y. So we continue. Need the bigger values of the x-axis. So I should take my y, match to the left that way. Sorry for that. You said you're supposed to subscribe. You're also requested to share so that you may invite a friend. This is a 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9, that way. Then 1, 2, 3, 4, 5, 6, 7, -1, -2, -3, -4, -5, -1, -2, -3, -4, -5, -6, -7, -8, that way. So we have the Cartesian plane well labeled. So the coordinates for A are 3, -1, 1, 3, 3, -1, that is where A is, then 1, 3, 1, 3 is the coordinate at this point, that's where B is. Then we are also having C. C is at 4, 2. So 4, 2 is a coordinate at this point. That's where C is. So with all these now, we can do the triangle AB, then C. From B to C, you connect that way. Then now we are having from C to A, that way. So this is the first triangle. Then the image now, we go to the coordinates of the image, -1, -3, -1, -3, the coordinate would be here, -1, -3. That means A will be at that point, that's A prime. We go again to -3, 1. So -3, 1 is a coordinate at this point. So this is where B prime is going to be. Then after that, we can talk about C, which is -4, -2. -4, -2, the coordinate shall be here. So this is C prime. With this now, we can connect them and come up with the second triangle. Come up with the second triangle. So A to B, then B to C. So we are having the two triangles now. Having the two triangles that way. Now, the reason why I did not use the first grid here is because the grid is not regular. You can see the grid is rectangular instead of being squared. So a grid should be very uniform with the sides of the bigger squares and even for the smaller squared being very equal. Therefore, when you observe this one keenly, you discover that it's a bit rectangular. This length is longer than this side. Therefore, they should be the same. You're supposed to be having a squared grid. So that's why I did not prefer this one. But after this, we've been taught to describe fully the transformation M. What is the transformation represented by this matrix? Now let's get back to our graph now, the graph that I have referred. So I should join a let me use a color that we have not used now. I join A and A prime, then I bisect. I join A to A prime, then I bisect. I also do the same for B, A to A prime. Then I also do the same for B and B prime. That way. Then I also do the same for B and C. Yeah, for C and B. I also join B and B prime that way. Then I bisect the line joining A. So let me come up with a bisector for the line joining A and A prime, and I should do so perpendicularly. So if I come up with a perpendicular bisector joining A prime, and also another one for B prime and C prime. Now the bisector confirms to be the same line. The line bisecting all of them proves to be the same. So the bisector is the same. Now, when you connect a point and its image, then you bisect, and you do the same for another point and its image, and you do the same, you bisect, then the bisector proves to be the same line. Then it means the transformation involved is a reflection, and the common bisector is the mirror line. So this one is the mirror line. This one is the mirror line. So it's a reflection, and the mirror line is here passing through the origin. So we check the kind of a mirror line it is. So basically, it is a reflection. And for you to describe a reflection, you mention that it is a reflection, then you have to come up with the equation of this mirror line. So this equation, you can see it passes through a few coordinates like 0, 0. It's also passing through a coordinate like this one, 1, -2. Coordinate like 1, -2. So we can find the gradient. To find gradient change in y over change in x, so -2 minus 0 divided by 1 minus 0 change in y. So -2 out of 1, the gradient is -2. So if the gradient is -2, that's m, and the y-intercept c is 0, then the equation will be y equals to -2x plus 0. So y equals to -2x. Line y equals to -2x. We should be having plus a certain y-intercept, but the y-intercept from the graph is 0. So this is the line. So you identify the mirror line, and you mention that it is a reflection that way. So it's a reflection line, y equals to -2x that way. So that's how you describe it. In the next question now, we are told that a triangle A double prime, B double prime, and C double prime is the image of A prime, B prime, C prime, and a transformation represented by the matrix N, 2, -1, -4, 3. Part 1, find the coordinates of A double prime, B double prime, C double prime, and draw on the same axis. Therefore, we should know that we repeat the same procedure of a matrix. The matrix should begin 2, -1, -4, 3. Then we multiply by A prime, B prime, -1, -3, -1, -3. Then something else that we have is -3, 1. Then at C, we're having -4, -2. That way. So we come up with the image. Again, in this multiplication, it will be row, column. This row times this column. Therefore, 2 into -1, -1 into -3, that way. So we are getting +1. Then in the next, the same row, the next column, such that 2 goes with -3, and -1 goes with 1. So that gives us a -7. -7. That way. Then now we are also talking about the same row and the last column. Same row, last column. So we will talk about 2 into -4 minus 1 into -2. This gives us -6. That way, -6. Such. Then after that, we talk about the other row there now. So we go to the lower row here and the same columns. So we begin -4. That one goes with -1. Then 3. 3 goes with -3. That way, this is -5. The other thing is -4 into -3 plus 3 into 1. That gives us 15. Then we go to -6. The last one, that is -4 into -4. Then plus 3 into -2. This is 10. You see now we are having the coordinates. A double prime is taking 1, -5. B double prime is taking -7, 15. C double prime is taking -6, 10. That way, -6, 10. Yeah, -6, 10. So those are the coordinates. Well calculated. In part 2, determine a single matrix that maps ABC on triangle A double prime, B double prime, and C double prime. Look at that. Look at that. A single matrix. So remember to plot this one. Remember to plot that one. A single matrix. This time round, the matrix is not known. We don't have a matrix. That would map the first triangle onto the last. So the first triangle is 3, -1, and 1, 3. Then is it 4, 2? Then 4, 2. A matrix that would multiply this one to directly give us that way. We come up with the matrix now. So the matrix is unknown and we're supposed to determine it. So we should be able to maneuver in such a question in this manner. Row multiplied by column should give us the first element. So we'll talk about 3A. B by -1 becomes -B equals to 1. You see with this now, we can express B. B to the right becomes positive. Equals to 3A minus 1 at way. Then again, we do the same row by the next column to give us -7. Therefore, A by 1, that's A, then 3B equals to -7. Those are two equations and can be solved simultaneously. Simultaneously in this way, in the second equation, where there is B, we can put 3A minus 1, such that A plus 3, and instead of B, 3A minus 1 equals to -7. So A plus 9A minus 3 equals to -7. You see, we are talking about 10A being equal to -4. 7 minus 3. 3 becomes positive. So 7 plus 3 becomes -4. So the value of A shall be, -0.4. If the value of A is -0.4, then the value of B is going to be, we substitute in this equation that gives us B. So 3 into -0.4. Then we subtract 1. That gives -2.2. -2.2. B equals to -2.2. 2.2. Negative 2.2. That is A and B. Now for B and C, we repeat the same procedure. Repeating the same procedure means we check for C and D now. The row that C at C and D with the first column to give us 3C, then negative D. This one should be the same as the first element there, which is negative 5. So this can be simplified as D equals to, we take D to the right where it becomes positive, and also 5 coming to the left becomes positive. So 3C plus 5, that way, 3C plus 5. The same row, CD, multiplied by the next column, should be C by 1 plus 3 by D. And this will be equal to the next, which is a 15. So now with this, we can work with substitution method again, whereby we have C plus 3, and instead of D, 3C plus 5, this is equal to 15. So C plus 9C plus 15 equals to 15. You see 15 and 15 will cancel. Then we'll be talking about 10C being equal to 0, and the value of C is 0. If the value of C is 0, then the value of D can be solved to be 3C plus 5. 3 times 0 is 0, plus 5, we get 5. So this matrix, which can map A, B, C onto A prime, B prime, C prime, double prime, that is, we'll get AC, negative 0.4, and B, negative 2.2. Then C is 0, and D is 5. That is the matrix responsible for such a transformation. Now at number 22, this is a question on longitudes and latitudes. We are told that the position of two towns P and Q are given as P, 40 degrees in the north, 10 in the west, and Q, 40 in the north, 170 in the east. Use pi 22/7 and radius of the earth 6371 kilometers. Part A, find the difference in longitude between the two towns. Difference in longitude means from the longitude where P is to the longitude where Q is. This way. This is 0 prime meridian. Then this is 0 equator. Then we are talking about longitude 40 degrees north. Now, along this longitude 40 degrees north, we have a place in the west that is 10 degrees in the west. And this is going to be P. Then 170 in the east. That is the farthest of east. This is 170 in the east. This is where place Q is. So from P to Q, what is the angle difference there? When two places are in opposite sides of the prime meridian, angle difference should be added. Therefore, the longitude difference should be 10 and 170. We move through an angle of 180 between the two places, 180 degrees. Then in part B, find the shortest distance from P to Q in kilometers, correct to 2 decimal places. Very serious instructions there. Actually, we are having 1 shortest distance, 2 in kilometers, 3 in 2 decimal places. Very serious instructions, all of them. So we're going to obey all these instructions. Now, when you look at the nature of P and Q, you discover that these are places on what we call supplementary longitudes. Supplementary longitudes are longitudes which are adding up to 180. 10 in the west, 170 in the east. Now, there is something wonderful about these longitudes. So, assuming that you are on the sphere, and these are the longitudes, we have the longitude 10 in the west, that is the North Pole. Then on the other side, there's longitude 170 in the east. This is the case whereby there's 180 here, when there is an angle of 180 there. So it is such that when you move from place P going to place Q, then you access the place through the North Pole, and you continue moving along the same line, you automatically assume the supplementary longitude. So if you are moving from or up to the north using 10 degrees in the west, upon reaching the North Pole and proceeding with the same route without negotiating any corner, just proceeding, you automatically enter 170 degrees in the east. Can I give another example? This is what we mean. If you're moving from a place here, let's say this is a longitude, this is another one, and this is the North Pole. So you move along this longitude, and let's say this longitude is a 75 degrees in the west. Then you move until you are at the North Pole. Then we'll just proceed with the journey downwards now, because you've reached the most top. You proceed now downwards. You negotiate downward now, but following the same route. You automatically enter 180 minus 75. That is 105. You automatically join the path with the longitude 105 in the east. So that's how supplementary longitudes are related. If you're moving with one and you reach the poles, you automatically assume the supplementary longitude to that one. Therefore, between P and Q, which are places on supplementary longitudes, you can use two distances here. You can move from P to Q across the parallel latitude. That is latitude 40 degrees. And that is a circle of a small latitude. And you can also access Q from P by the North Pole now, as we have drawn. So the argument here is, when you access Q through the North Pole, the route is usually shorter than here. This one is through 40 degrees north, but now this one up here is through the North Pole. So through the North Pole, it is usually shorter than across the parallel latitude. When you use the North Pole, you will be using what you call a great circle. A great circle, and the great circle will be this way. If this is equator, the great circle will be this way. This is how the great circle will be. The great circle PQ, the arc PQ, will be having an angle at the center. So how do we identify the angle at the center? From equator to where P is, we have 40 degrees. From equator to where Q is, there is 40 degrees. If that is so, then the angle at the middle will be 180 minus 240s for us to get exactly 100 degrees. Actually, so we have an angle of 100 for that arc PQ now, 100 degrees. So now we say distance in kilometers along a great circle is usually given by angle difference over 360 to pi r. 100 over 360 to pi r. So let's get the distance. 100 multiplied by 2 multiplied by 22 multiplied by 63, 71, divide by 360 and 7, And this gives us 11,123.97 kilometers. The distance is now in kilometers. It is along the shortest route, and the distance is expressed to 2 decimal places. Very simple. Let's look at part C. A ship sailed from town P towards town R, which is directly east of P, covering a distance of 2,000 kilometers. Determine the position of R. Determine the position of R. So for us to get the position of R, we must know that because this ship is sailing towards the east, then it's moving along a parallel of latitude, which is a small circle. The distance has already been provided and it is in kilometers. So distance in kilometers along a small circle is usually given by the angle difference over 360 2 pi r cosine of the latitude. Therefore, we talk about the distance, which is already known, 2,000. This is equal to a known longitude difference over 360 multiplied by 2 multiplied by 22 over 7. That is the pi multiplied by 63.71 cosine of latitude 40. Because we are already at P, which is 40 degrees in the north, then we are moving towards the east. So we are moving along 40 degrees in the north. So for us to get the alpha here, the normal changing of the subject in a given formula, 2,000, we multiply this by 360. We also multiply by 7 because they are the denominators. Then we divide this by, you open brackets, 2 by 22, then again by 63.71, the cosine of 40. This is giving us 23.47. 23.47. That is the longitude difference that we go through. Now, logically, when we look at P, you know, P is already at 10 in the west, but now we are moving through an angle of 23.47 towards the east. This is to mean that we have already covered the 10 degrees from P to the prime meridian, and we are now past the prime meridian. So we are on the opposite side. That's why we say the angle difference of 23.47 has been gotten by 10 plus their known longitude of position R. So for us to get X, we subtract 10, 13.47. This one is the longitude of R, and it is in the east. In case we got an angle difference, which is smaller than 10, in case we had an angle difference smaller than 10, then we would say that we have not moved beyond prime meridian. We are still within the west. But now that we are getting more than 10, then we have already transitioned to the east side. So it is 13.47 in the east. And therefore, position of R should now be given. Remember, position begins with the latitude. We are still at 40 in the north, 13.47 degrees in the east. So that's how we give the position. That's how we give the position. Then look at part 2 of the same question, which is now the last part to be handled in this question. We are told that the ship departed P at 2 p.m., sailing at an average speed of 150 knots. Find the local time at R when the ship arrived. When you are told that speed is in knots, this means we are having 150 nautical miles in every hour. So the distance has been considered in nautical miles. That means we have to work with nautical miles for us to know time. So distance along a small circle and in nautical miles is usually given by the 60 multiplied by the longitude difference cosine of the latitude where the two places are. Therefore, the distance 60 multiplied by from P to R, we are having 23.47, then cosine of 40 degrees in the north. This shall give us 60 by cos 40. This gives us 1078.75. 1078.75 nautical miles. Now with this, we're supposed to know that because the distance from P to R is known in nautical miles, then we can get the time this ship took. So time taken should be the distance out of the speed of 150. This gives us 7 hours, 0.19. So 0.19 should be multiplied by 60 to give us minutes. These are 11 minutes. Yeah, 7 hours, 11 minutes. 7 hours, 11 minutes. Therefore, this is the time taken. Then we talk about time difference now. P and R are not places on the same longitudes. They are in different time zones. So when the time zones are different due to the longitude differences, then now we need to talk about time conversion there. At the time it was 2 p.m. at P, it wasn't 2 p.m. at R. R is to the east, so R is ahead in time. This is how we calculate the time difference. We usually say that considering that the 360 degrees in the globe of the Earth are rotated in one day within 24 hours times 60 minutes. These are minutes. What about one longitude of 1 degree? To be 24 by 60 times 1 over 360. This gives us 4 minutes. So there is a 4 minutes time difference within every 1 degree. 4 minutes time difference. Therefore, if there are 4 minutes for 1 degree, what about the longitude in difference, the different longitude here? What about the different longitude here? Whereby from P to R, there is a longitude difference of 23.47. So one degree is 4 minutes time difference. What about 23.47 degrees? To be 4 times 23.47. So 4 times 23.47. This gives us 93.88 minutes. So if these are minutes, then we can make them hours. We have 1 hour, 60 minutes. Then we will have 33 minutes remaining. Yeah, we will not express the seconds part. And actually, yeah, we may not express the seconds part because seconds will not feature in the watch. So we have 1 hour, 33 minutes. So in this case now, we are supposed to know that the place R is ahead in time by 1 hour, 33 minutes. Therefore, we will say from 2 p.m., which is 1400 hours, we are adding 7 hours, 11 minutes. That's the time taken. Then now time is already ahead in this place by 1 hour, 33 minutes that way. So we add 7 hours, the time to travel, calculated here. Then the time difference now, because the place R is ahead in time, because it is to the east. If it was to the west, we would have subtracted, because places in the west are behind in time. 11 minutes plus 33 gives us 44 minutes. Then we are having a 14 plus 7 plus 1. That's 22. 44 hours. That will be the arrival time of the plane at place R. So questions dealing with longitudes and time should be taken very serious, more so when there is what we are calling time difference between two places. Otherwise, remember to support our programs by sending your support through the till number on the board, 49777742. Any amount is going to be appreciated. Thank you so much for being part of this program. See you next time.